Hey golfers, Coach Mark here. Today we're going to do a quick lesson about rotational speed, followed by a fun activity where we're going to make a toy. So let's begin. Okay, I want to teach you about spin rate. A golf ball's spin rate refers to the speed that it spins on its axis when it's in the air, when it's in flight. And that spin rate is measured in revolutions per minute, or RPM. In science, we refer to the golf ball's spin rate as its rotational speed. Okay, so those are kind of the same thing, spin rate, rotational speed. Depending on which club you use, you're going to get a different spin rate. This is your driver right here. When you hit the golf ball with this, you hit it really far, but you don't give it too much of a spin, really. With a driver, the golf ball will usually spin about 2,000 to 4,000 RPMs, that's revolutions per minute, in the air. And that sounds like a lot, but when you hit it with your wedge, these grooves on the wedge actually kind of grip the ball and then launch it into a real spin. And when you hit it with your wedge, you can get as many as 10,000 RPM, or revolutions per minute. So that's a lot more than with your driver. So the wedge is the club that gives you the highest rotational speed, or spin rate, on your golf ball. As the golf ball is in the air, the spin of it actually helps to generate lift. It kind of pushes it farther into the air as it's spinning. And that results in a longer shot. But poor backspin, if you don't get enough spin on it when you hit it, that can cause the ball to slice to the left or to the right. And you don't want that. You don't want it to hook or to slice. Sometimes it's going to land on the rough, like this. And when it lands on the rough, you need to be really careful as you use your wedge, because the long grass can get in between the ball and the wedge, the grooves on the wedge, and it will actually prevent it from gripping these grooves that you see on the wedge, which means that you won't get as much spin as you need. You can think about that like if you were to throw a baseball and you wanted to get a really good grip on it, but you were wearing some kind of like a slick glove and you couldn't get the right grip on it, you wouldn't be able to throw it with accuracy. It's the same thing with a golf club and the grass between the ball. The last thing that I want you to know in this lesson is that if you get the ideal golf spin, the ideal spin on the golf ball, it's going to carry the ball for a longer distance, but because it's spinning, when it hits the ground, the spin actually causes it to stop a little bit faster too. And that's usually good. If you have good aim and you can get to the green, the backspin helps to stop before it rolls off the green. To learn about rotational speed, we're going to do an investigation by building a toy. The cool thing about this toy is that you only need some string, tape, 2 paper plates, something to poke a hole with, scissors, and markers. Let's begin. The first thing you want to do is take your paper plates. The thicker, the better. They don't have to look exactly like this, whatever paper plates you have, but if you have thick ones, it's going to go better than if you have thin ones. So take your paper plates, put one on top of the other, like this, and then you're going to tape it shut. So you're just going to try to make sure it's even with no overlap, and tape it shut like that. But I'm going to put some pieces of tape all the way around it so it doesn't swish around. Cool, I got it taped together. The next thing I'm going to do is I'm going to take my poker and I'm going to find the middle of this and I'm going to poke a hole all the way through to the other side. I need you to be really careful when you do this. If you are a little bit worried, you can definitely give it to an adult or somebody that you trust to poke the hole for you, but be careful, okay? So this is about the middle. Poke, I'm going to try to go straight through like that, and then just sort of, probably the bigger the hole the better, so if you want to wiggle it around a little, could help. If you have a hole punch, that might work even better than this thing. There we go, now I have a hole through there. Now I'm going to take my string and I'm going to cut, like 3 or 4 feet of it. Doesn't have to be exact, but I'm going to cut about a 3 or 4 foot length of string. Go. I've got my string here, and now I'm going to put it through the hole. Okay, there we go. I'm just going to kind of pull it through so that I have some string on both sides. And then the last thing that you want to do before you play with it is you want to put this big black mark on it. It's just something like this because what you are going to do with the toy is you're going to make it spin. And you want to see how many times it goes around by looking at that black mark. So you need that thing. So how does it work? When you twist the string, you apply torque or rotational force to the paper disc, which causes it to spin. Okay, as the disc builds up speed and the string kind of unwinds, the speed keeps going because of inertia. And you'll find that even when you stop twisting the string yourself, the disc keeps going. That's the inertia. For advanced practice, you can set a timer and then you can time for 10 seconds and see how many spins your toy does in 10 seconds. And the way that you see how many spins it is you see this black mark, and however many times that turns around in 10 seconds, you need to write that down. So let's try that now. Okay, you start your timer for 10 seconds, which I can't do because I only have one hand here. And then, using my foot. Okay, I'm gonna get it spinning. I'm gonna count how many times it goes around. I can barely see it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and that was about 10 seconds. So that was what, 13 spins? So I'm going to write down 13. And I want to find how many times it would spin per minute. So I did 10 seconds, and there are 60 seconds in a minute. So I need to do 13 times 6, which gives me 6 times 3 is 18. Carry the 1. 6 plus 1 is 7. So 78 is my RPM, revolutions per minute, or spins per minute. So that's how many times my toy spins in a minute. How many times does yours?